To look at regions today. So, inequalities can be shown as regions in a Cartesian plane. So we're just going to look at some examples. Now, the simplest type that you can be asked to sketch is to sketch something like x is less than or equal to -3. To be able to sketch that, first we sketch the line x equals 3. Okay, see, this is the line x equals 3. And we do it as a solid, we draw it as a solid line because, so you will draw the line first. You'll either draw it solid or dotted. You will draw the line dotted. You know, if I ask you if x is less than 3, just the point, you put a circle around 3 and do an arrow down, okay? But with this, x is less than or equal to 3, we draw a solid line because it can be 3, okay? So we're sketching the line x equals 3, and then we're shading in all of the x values that this function can take on, or that this relation can take on. So if x is less than 3, then x could be 2, x could be 1, etc., 0. So we shade the left-hand side of the graph. This left-hand side of the graph shows you where all the x values can be less than or equal to 3. Equal 3 is on the line. Now, why are we not just drawing a number line? Because we're shading a region. I could have the point -2, 1. That point -2, 1, for example, has an x value less than 3. Okay, so we're shading regions here. This is not the number line. This is the number plane, and we're shading regions. Okay, so sketch the region, and they will say sketch the region. All right, x is less than or equal to 3. Okay, now, this one, sketch the region y is greater than -1. You draw the line y equals -1, but you draw it as a dotted line because it doesn't, y equals -1 is not included. So we draw it as a broken line. So there's y equals -1 there, but you draw it as a dotted line because -1 is not included. And we want y to be greater than -1. Where are the y values greater than 1? They're up here. Okay, so we shade in that region. All right, so do you want to quickly sketch those two in your book? So we're going to sketch x is less than or equal to 3, y is greater than -1. Just showing those there, x is less than or equal to -3, x is greater than -1. Plus types, your horizontal and your vertical lines, okay? Now we're going to sketch y is greater than or equal to x plus 2. First we sketch y equals x plus 2. So y equals x plus 2 is a straight line. Let's just do, you can quickly sketch it by working out the x-intercept and the y-intercept. So when x is 0, what's y? 2. And when y is 0, what's x? -2. That's the quickest way. X and y-intercept. Okay, now we have to decide where are we going to shade. So this is the line y equals x plus 2. Okay, it's solid because it's greater than or equal to. So now I test a point on either side of the line to see whether I shade up here or whether I shade down there. Now, an easy point to test is 0, 0. So I'm going to test 0, 0, and that means x is 0, y is 0, and put it into the inequality, not into the equation of the line. It doesn't lie on the line 0, 0. So there's the line. Do I shade down here or do I shade up there? I test a point on either side of the line. Which point do I test? The easiest point you can find. 0, 0 is always a good one. So you test that in the inequality, not in the line. It doesn't lie on the line. So I've got 0 is greater than or equal to 0 plus 2. 0 is greater than or equal to 2. Is that true or false? That is false. So therefore, I don't shade down here. Do you get it? I shade on the other side. So I shade up here. Now, let's pick a point just to check. So we shade on the other side. Give me a point that would definitely lie over here. Don't get something too close to the line. I'm thinking -2, 2 up here. So let's just check. If we did try, say, -2, 2, you would go 2 is greater than or equal to -2 plus 2. 2 is greater than or equal to 0. That is true. So yes, we have shaded on the correct side of the line. Yep. It's the -x² curve. Shift it up 2 units and it should be dotted. Okay. So it's dotted. Okay. Now I have to decide. So put some arrows. Any idea what the x-intercepts would be? Putting that equal to 0. Negative x squared plus 2 equals 0. That means that x squared is 2. X is plus or minus the square root of 2. So where do we have to either shade underneath here or outside? Let's test the easiest point, which would be 0, 0. And we put it into the inequality, not onto the function itself. In the inequality, so you get 0 equals negative 0 squared, sorry, is greater than. So 0 is greater than 2. True or false? False. So therefore, it does not lie. It does not lie there. So therefore, 0, 0 does not satisfy. So therefore, 0, 0 does not satisfy the inequality. Does not, well, I've written false anyway. Does not satisfy the inequality. So therefore, it lies out here. If it does satisfy the inequality, you shade inside there. Okay?
And it never works inside or outside?
No, it always will work for one of them. It will work for one of them. So if I had the value, if I had y is less than, I would have just shaded in there. Okay? Represented by x squared plus y squared is less than or equal to 16. First, we sketch x squared plus y squared equals 16, which is a circle. Center, what? 0, 0. Radius, 4. So we sketch our circle. Oh, bad drawing. So now we have to decide whether we shade inside or outside. Just having a look at that inequality, where do you think you might shade? Yeah, inside. But so what are we going to test? Test 0, 0. If the line passes through 0, 0, you can't test 0, 0. So we're going to test 0, 0. So 0 squared plus 0 squared is less than or equal to 16. 0 is less than or equal to 16. That is true. Therefore, you shade inside. Region. What is this? It's a? So it's a circle. Center 3, negative 1, radius 2. So 3, negative 1, 1, 2, 3, negative, there, negative 1, radius 2. Look, it's not to scale, okay? But if this is 3 and the radius is 2, it's going to come about here. So it looks like this. You are going to have to indicate where your endpoints are if you're doing a sketch, and your center. So 3, negative 1. This is the point. So aren't we going 2 up, 2 down? So what have we got? So what's this point? What's 2 up from negative 1? So this is 3, 1. This is 3, negative 3. This is 5, negative 1. And this is 1, negative 1. Okay. So we've sketched the circle. Now, where do you think it's going to be shaded? In or out? Anyway, we'll try. Let's pick a point.
0, 0.
Substitute the point 0, 0. That's lying outside, okay? So we've got, what have we got? Negative 3 squared plus 1 squared is greater than or equal to 4. What have we got? 9 plus 1? 10 is greater than or equal to 4. That satisfies the inequality, like it's true. So therefore we shade outside. Okay, so we shade outside. So shade the next one, shade the region. represented by the inequality y is greater than or equal to, actually I might do y is less than or equal to as well. Shade the region for y is greater than or equal to 3 to the power of x. That's 3 to the power of x. What sort of curve is that? Exponential curve. Substitute a few points. You need to, if they're asking you to shade the region, you need to sketch the graph with a minimum. You need 2 points indicated on the graph. 1 point is not enough, because for every exponential function, when x is 0, y is 1, right? But that could be any exponential function if I just go like that. So I need another point. When x is 1, y is. Doesn't have to be to scale. As long as I've got 2 points, and we know that it goes like that down there. So I need at least 2 points indicated. I'm just going to put the 1 over here. So there's your function. What point are you going to test? So I'll just get rid of this from here. I'll do a less than with a combined type. So we're going to test the point 0, 0, because that's down here. It is on one side. So what do we get? 0 is greater than or equal to 3 to the power of 0. 0 is greater than or equal to 1. That is false, not true. So we do not shade below. We shade above, but let's just check. Let's test the point. What point could you test? You don't have to go into the negatives if you don't want. You could test like 0, 2. Do you get it? You could test 0, 2. That's x is 0, y is 2. So I've got 2 is greater than or equal to 3 to the power of 0. 2 is greater than or equal to 1. That's true. Okay? So the point 2, 1 is up here. That's fine. You would shade there. Now we're going to do some overlap of regions. Region bounded by these curves. Y equals x squared. I'd be putting a bit of detail because you need to go out. Y equals x squared, x-axis, and the lines, x equals 1 and x equals 3. I'm not going to be able to draw it to scale because, so I need to draw my x squared curve out to at least x is 3, okay? So what about when x is 3? What's y? 9, so I should have allowed a bit more space here, but I'm going to make, I'm going to go 2, 4, 6. Yeah, actually, I'll move it down. Markings on the x-axis. I'm not going to put markings on the y-axis, okay? So I've got 3, 9. We okay with that? What about when x is 2? Y is 4. I'm drawing the parabola. When x is 1, y is 1. Now, notice I'm not putting markings on the x-axis. I'm just going to indicate these points. I've got 1, 1. And then we just come back here for the mirror image. Okay? Etc. So this is y equals x squared. I have indicated the values where x is 1. I did put a scale here, but I didn't put a scale on the vertical axis. So I need to shade the region bounded by the curve. So I've drawn y equals x squared. The line, we've got the x-axis here. The lines x equals 1. Now this is x equals 1. Got it? And this is the line x equals 3. Now, which region is bounded by the curve, the line x equals 1, the x-axis, and the line x equals 3? It'll be what's inside them. It's bounded by all those graphs. It's bounded by x is 3, x equals 3, x equals 1, the x-axis, and the curve. It's all in here. So that region is bound by y equals x squared. See, if they didn't mention the x-axis, you wouldn't know whether you shade up the top or down the bottom. Do you get it? So it's bounded by the x-axis. So down here, it's bounded by the line x equals 1. It's bounded by the line x equals 3, and it's bounded by the curve. So it's in there. The 0.39. that this is the 0.11. Okay. All right, the next one. Shade the region bounded by the curves. Y equals 1 over x plus 2. Now that is a what? No, hyperbola. Hyperbola shifted. What makes x plus 2 equal to 0? X is negative 2. So shifted 2 to the left, asymptote there. Which quadrants? Just making sure I write. Yeah, which quadrants would you sketch this? Isn't it the positive 1 and 3? Okay, so y equals 1 over x plus 2. It needs to be a fairly accurate drawing. So when x is negative 1, what's y? 1. When x is 0, what's y? When x is 0, y is a half. Okay. When x is 1, y is a third, etc. It looks like this. And this will go up like that. Okay? Now, and I can draw down, the other bit will be down here as well. Okay, now I can stick a point here. Say when x is negative 3, it's 1 over negative 1, it's negative 1. Negative 3, negative 1. Okay, that's negative 3, negative 1. Now, I want to sketch the region bounded by this curve. So by this curve, the x-axis and the lines x equals 0. Now this is the line x equals 0. And the line x equals 2. That's the line x equals 2. And the x-axis, which lies across like that. Where do you think I'm shading? In that little bit. Bounded by this curve. I mean, the curve's over there as well. But it's nowhere near x is 0 and 2, all right? X is 0, x is 2, and the x-axis, it's in here. Okay? So shade the region bounded by these three, by these curves. So they're all inequalities, okay? So shade the region bounded by these three inequalities. So first I'm going to sketch y equals 1 minus x. Now what's that, positive or negative gradient? Let's just do when, so first I'll sketch y equals 1 minus x first. What do we get? When x is 0, y is 1. When y is 0, x is 1, when y is 0, sorry, it's this way, x is 1. This is y equals 1 minus x. Negative gradient, isn't it? Negative gradient, y-intercept 1. That's your first graph. Y equals 1 minus x. So we want to sketch the equal graphs first. Sketch y equals 1 minus x. Sketch equals 2x plus 1. Just think, what does it look like, 2x plus 1? Y-intercept is 1. Doesn't it go this way? Positive gradient of 2. We're not going to do rise over 1. We're just going to sketch another point. When x is 1, what's y? It's 3. Positive 3. When x is 1, y is 3. That's the second line. You can put when y is 0, I think we get negative a half. So that's your second line, y equals 2x plus 1. So we're sketching the three lines. They're all less than or equal to, which is like, or equal to, which means we can draw them all solid. The third line, let's just do x-intercept, is put y is 0. What do you get? We're trying to solve 2x minus 3y equals, we're trying to sketch 2x minus 3y equals 6. When for x-intercept put y is 0, we get x is 3. And for y-intercept put x is 0 and we get negative 2. So, and if I do rearrange it, I get, it's got a positive gradient. So y-intercept's negative 2, x-intercept is, sorry, wrong way. X-intercept is 3, y-intercept is negative 2. Oh. So it looks something like this. Now, we have to shade. Now, look, 0, 0 lies in the middle of them all. We have to try 0, 0 for all of them. So we're going to test 0, 0 because it's a good one to test because so you've got to test it with each line separately. So let's check it with y equals 1, y is less than or equal to 1 minus x. 0 is less than or equal to 1 minus 0, that's true. So we know for the example, this first line, we would shade here. Does that make sense? So for y is less than or equal to 1 minus x, don't do the shading, we would go there. Okay? Then we're going to test 0, 0 for, let's look at this line. Y is less than or equal to 2x plus 1. 0 is less than or equal to 1. True. So for this one, we'd shade where the 0, 0 is as well. And then the third line, 2x minus 3y is less than or equal to 6. We're going to test 0, 0 again. And we get 0 minus 0 is less than or equal to 6. That's also true. This was this line. Now 0, 0 lies above that one. So I've shaded down here. I've shaded down there. And I've shaded here. Can you see the intersection of the three? It's in the triangle. If I was to shade them all up there, there, and down here, the intersection is in the middle.